The objectives of this project is to create a website where a video, a PDF file, or an image can be translated into metadata to be searched in the future. The Navy has a large amount of training data that they want to be able to have a website to search for it. When you find relevant metadata, it will provide a link that you can click, and it will bring you to the page number of the PDF, the minute of the video that the metadata is in, or an OCR text representation metadata that will bring you to the image that that information is in. This will greatly help them teach more information with all the training documents that they have. Requirements for this project was the system should be able to process PDF to text documents, and then it'll take the text from the documents and summarize it, creating a metadata tag. And then the information will be stored in a database with what page number in the PDF the text was found. This was also to be done for video files, and the approach for that was to parse the video files into 30-second increments, and then also create metadata for that text and store that along with the time that that information was found in the video file. It was also designed to process PDFs that were actual images and not text PDFs. So that would use OCR, optical character recognition, to do the same thing. Store the page number, convert the actual image into text. Then, after all that information was gathered out of the different file types, the information would be stored in a database where it could be searched. So then users could go onto the website, enter some keywords, it would search the database and return all the different documents with the time in a video file, the page of an image, or the page of text where that information was stored. The design of the project will have a web client, web server, and then basically a LAMP server, which would be running on an Ubuntu Linux environment. And then we would use Python, PHP, and T5 and TextRank scripts that would run through the content stored in the database. And then there would also be a search function to extract that information. Here's an activity diagram of the data flow. So we have a different flow whether you're processing a video file, because it has to convert the audio from the video file to text. Or if you're processing a PDF file, it can just read the text, and then when it encounters a tag for an image, it can attempt to modify the image into text using OCR. And then finally, there's a search function that will go and extract the information from the database and return it to the user. How we implemented the project was we contacted OIT at FAU and requested an Ubuntu VM to be created on their Linux server. We used the Linux server front-end GUI to upload all our standalone files that we had been working on. And then we secure copied the data files, scripts, web files, etc., over to our VM, the Ubuntu VM. And then we built out the directory structure. We moved all the files to the corresponding directories. We set up the permissions accordingly. And then we wanted a better name, since this is a Navy project with the National Security Institute. So we had a DNS name set up to also hit the index file, which is in the var www HTML directory. So they set up, OIT set up a DNS name for that, NSINFAU meta. Then we installed all the needed Python files because we're using libraries for the convert to text from a PDF, the audio conversion, and the OCR conversion. Then we decided to go with a PostgreSQL database. So we installed that. And then we debugged. We got all our code running. Basically, you have a front end index file that has forms that calls PHP code. The PHP handles uploading the files. And then the PHP also runs an exec command that executes our Python code on the files. And then the Python code writes it to the database.
So for the project implementation for the video transcript, the first step is to upload the file to the website, and the website will actually store it. Next, it's going to check the file and break it into 30-second intervals. This is all done with the Python script, this next part. Then the Python is going to run the Google speech recognition to generate the transcript for each interval. And then it will run TextRank to generate the metadata content tags that will most accurately describe each piece, each interval. And then finally, when all that's run, it's going to store the file name, the timestamp, the metadata, and the transcript to the database. Project testing was done in multiple stages. In the beginning, we just started with our own Google Docs and tried to get our Python scripts functional to the requirements that we needed. Then, when it was all set up, we put what we had created on Google Docs onto a Ubuntu server, and using the Linux box is how we conducted our testing to ensure that we could actually run it on the server. Finally, after getting all that, we implemented the website, and from the website we were able to actually upload our files and run the scripts on the files, and then we were doing our testing from the website itself.
So in short, for just a PDF conversion, you go to the website, you have a search file, which is the PHP, the form on the index HTML executes the PHP file, which opens a browser to select your file, and then you hit submit, And then after it's uploaded, the PHP will execute the Python script that parses all the code, parses all the text in the PDF file by page. Then each page, text rank is run on it to create metadata. Then it'll store the file name, page number, metadata, and page text in a list of lists in Python. And then it'll write that information into the database.
And in our last feature from our project, we have the OCR PDF to text, which really basically consists of feeding our website of a PDF with pictures and text on it. The code will be run on a Python script and will identify the image tags inside the PDF, and it will return them as outputs, which then will become the inputs of the TestRec program, and then that text inside the pictures will be labeled and stored and saved in the database for access.
So for our website development, what we did was our code needs to be run on a front-end website. We decided to take a Bootstrap template that would best fit our needs and modify it in a way that is best for the users that are going to be using this and just for testing overall. Next, we need to create the PHP file for each modal. So when you click on the process PDF or the process video, it opens up a modal which will prompt the user for a file. Once the user selects the file and hits the process button, that's where the PHP file runs an execute code on the Python script that needs to be run. And once the website will process running the Python script until it's done, it will show what was outputted by the Python script, and it will store everything as well into the PostgreSQL database. So for the database development, we chose PostgreSQL as our database, as it's one of the best for the Ubuntu server. Below is the table for PDF and video text. So we use two separate tables to store our data, because we have our two main sources will be users uploading files and the other users uploading videos. So each table will get the data pushed into the correct table, and so both of them pretty much store the name of the file, the page number or timestamp, the metadata, and the actual content inside the file. So for the video, it would be the transcript, and for the PDF, it would be the page on the page. Alright, this is the video demonstration for the method content tagging for the video portion. So this is the front end of the website where we can click on the process video. This will take us to the process video modal where we can select our file and hit the process button to execute the Python script on it. So I went ahead and, just to save some time, I went ahead and selected a video about Vice President Harris being accused of running for President 2024. So here is the output. It's a little sloppy, but this is just for testing purposes. So it does take the video, and it was a minute 30 seconds long, so it breaks that into 4 different parts, and it'll store each of these parts in the metadata, which, as you can see some here, this is the metadata. I'll show it. This is where it actually goes into the database. So first we have to connect to the Postgres, and get into the right table. And now here, I'll show the two tables we have. It's one for the PDF, one for the video. So I'll just do a quick select all for the video, and on the bottom here is where we have the latest. So it stores the the actual transcript here on the last portion. It's got the metadata for that section, the time in which it was done at in seconds, and then the name, and then of course you got the serial number. And that's the video demonstration.